Hi girls, so we are back to continue looking at the Pythagorean theorem. Today we're going to be looking at the converse of that theorem and then also how it relates to triangles that are acute or obtuse. So we'll run through a couple of examples together and then you'll have a little assignment to practice these skills. So let's get started with the converse of the Pythagorean theorem. So I just wrote that out for you. If the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So basically it's just what we talked about in our last class, but flipped. So in other words, if we take a look at our statement down here, if c squared equals a squared plus b squared, then we know that ABC is a right triangle. So in other words, if I squared the side C and I squared the side A and squared the side B, but I added A and B together, I should get C. And if that works out, then I know that this triangle is a right triangle. All right, so let's see how that applies to some problems. So I've got two examples here. I'm going to run through the first one with you, and then for the second one, you could pause the video and check your answer. So we are trying to determine whether this triangle is a right triangle. So really, is this angle 90 degrees? So we're going to set this up where we have, again, we're going to use a squared plus b squared equals c squared. And I'm just going to real quickly label the side. So if I'm trying to check if this is my right angle, I'm going to assume that this would be my longest side, which is my hypotenuse, or C. And then I can label the other two sides with A and B. So now we just plug the numbers in and see if they are in fact equal to each other. So I'm going to plug in 8 for A, and I'm going to plug in 7 for B, and I'm going to see if that is equal to the square root of 113 squared. All right, so 8 squared I know is 64, and 7 squared is 49. And then if I take the square of a square root, what that does is that undoes the radical, so I just get an answer of 113. So now I just need to check to see is 64 plus 49, that in fact gives me 113. So if 113 is equal to 113, therefore, yes, this triangle is a right triangle. So I can go ahead and put that right angle symbol in. All right, so go ahead and pause the video and see if you can figure out if that second example is a right triangle. Okay, so we are trying to determine whether this angle here is a right angle. So again, if I'm looking at what my hypotenuse is, that is across from my right angle or supposed right angle. So I'm going to label that C, and then I'm going to label my other sides A and B. So using the converse of the Pythagorean theorem, I'm going to say that A squared, which is 15, and B squared, which is 36, I'm checking to see if that is the same as 4 square root 95, that squared would equal that. So let's go ahead and calculate what 15 squared is. So that would give me 225. And then 36 squared is 1,298. And then I'm going to square this other side. So you may remember this from Algebra 1, but if not, this is a quick refresher. So you need to square everything in this parentheses. So that means that you're multiplying it by itself. So 4 times 4 is 16. And then if you remember the last example, when you square a square root, it undoes that radical sign. So then you're just multiplying it by 95. All right, so use your calculator to go ahead and add these two together. So you will get 1,523. And then on this side, I get 1,520. So what do you notice? That they're not the same. So these are in fact not equal. So therefore, this is not a right triangle. Okay, so now let's scroll down and look at a couple of other applications where we are seeing about how these relate to acute or obtuse angles. All right, so for any triangle ABC, where C is the length of the longest side, the following statements are true. So if you take C squared and that ends up being smaller than the sum of the squares of A and B, then we can say that triangle ABC is considered to be an acute triangle. And then obviously, if C squared is larger than the sum of A squared plus B squared, then the triangle ABC is considered to be obtuse. So if you want to mark those angles, you can see that all of the angles in this triangle happen to be less than 90, so these are all acute angles. And then over here, we've got one obtuse angle, right? So that's where this obtuse notation comes from. All right, so let's take a look at the example and use our inequalities. So in example 2, they ask us to verify that the segments form a triangle. And then if it does make a triangle, then we want to find out if it's acute, right, or obtuse. So the first thing we need to do is determine whether this makes a triangle. So this is a little bit of a review. If you remember, we would check the lengths of the sides to see if, when we added two of the sides, if they were greater than the third side. So to check to see if this is a triangle, you have to do three different addition statements. So first we're going to check if we add the first two legs together, is it bigger than the last leg? So we're going to ask ourselves, is 4.3 plus 5.2 larger than 6.1? So I think we can all agree that that in fact is true. Now let's try another combination. What about 4.3 and 6.1? Can we say that is larger than 5.2? And I think we can see again that that is true. And then finally, we need to add 5.2 plus 6.1, and is that larger than 4.3? And in fact, yes, that is. So therefore, by these statements, we do have a triangle. So yes, triangle. Now what we want to do is find out what kind of triangle this is. Is it acute, is it right, or obtuse? So we're going to label these numbers with A, B, and C, remembering that C has to be the larger of the numbers. So then we need to check, is 4.3 squared plus 5.2 squared, how does that relate? So we're going to try to find out what that is. Is it greater than, less than, or equal to 6.1 squared? So let's go ahead and use our calculator to find the answer to that. So when I do 4.3 squared plus 5.2 squared, I can do that all in one step in my calculator, and I will get an answer of 45.53. And then 6.1 squared gives me an answer of 37.21. So how do these two numbers compare? Well, 45.53 is greater than. So if A squared plus B squared is greater than C, if I go back up to my notes here, this is greater than C, then my triangle must be acute. So it is an acute triangle. All right, so go ahead and pause the video and see if you can figure out if one, part B, makes a triangle, and then two, what kind of triangle it is. Okay, so just like in the last example, we first need to check to see if this is a triangle. So we have to add our different combinations. So if I take 14 plus 15 and I compare that to 11, that is true. If I take 14 plus 11 and I compare that to 15, that is greater. And then finally, if I take 11 plus 15, is that greater than 14? And that is also true. So yes, this is a triangle. Now let's check to see what kind of triangle it is. So let's go ahead and label up here. So I'm going to call this A, this B, and this one C, because C, again, remember, is our largest side. So I'm going to take 11 squared plus 14 squared, and I'm going to see how that compares to 15 squared. So if I go ahead and add 11 squared plus 14 squared, I should get an answer of 317. And then 15 squared, I know, is 225. So 317 is larger than 225. So just like our last example, the sum of a squared and b squared is greater. So then that means that this must be an acute triangle. All right, so you have a couple of practice problems that you'll work on out of your textbook, and you can check your answers and follow along. Please feel free to reach out on Google Meet if you are having trouble with this or if you want to go over one of the examples from the homework. All right, talk to you soon. Bye.